Welcome to Philosophising. Nathan and I forgot that we didn't know how to read a calendar. Basically, we are on this week, and we're actually off next week.
Yep, yeah, that's what happened. So kind of speaking of which, we're gonna continue talking about neurodegenerative diseases.
For
um,
those of you who are joining us for the first time, we're philosophizing.
Nathan,
I'm Ruby, and we philosophize about science. And this week, we wanted to talk about neuroethics
yeah,
on the back end of a entire lecture on Huntington's disease.
right, yeah, just like so if you've been on our stream for a while, I think kind of like a trend is that we like depressing topics. Um, like the the Huntington stream was actually like surprisingly uplifting. I was like, oh, we finally have a way to treat this thing. So that was good. But yeah, actually, I think so one of the reasons I wanted to do a neuroethics stream was so I teach a class on cognitive enhancement technology. And a couple of weeks ago, we I did a lecture on kind of the ethical aspects around this technology, and like people are very checked out and didn't really care, which I found sad because I was like, this is like the coolest and most interesting like part of it that we're going to talk about. So this is like the redo where we get to talk about it and like be more interested in it, because I was just like, isn't this important? Like this is like the most important thing about this technology, and everyone's just kind of sitting there. It was kind of sad. I was just like, this is how technology, like these are the questions that determine like whether inventing this technology is a good thing or a bad thing. And I'm just like, how are you not psyched about this? But
And as the audience of one plus the internet, I will make up for the
thanks,
entirety of Nathan's
thanks,
sad
Ruby.
class.
Yeah. But yeah, no, I mean, I think that I think that is like to me, I find it interesting, like a as an intellectual exercise, because it really makes you think about your own ethics, and it makes you think about things in ways that you haven't thought about them before, and like also because it's just incredibly important. I mean, and when we talk about these things, we're talking about things that will like probably influence your life at some point, will influence millions of people's lives. Like I do think it's like the most important thing we do as neuroscientists is to think about and work on the ethical implications of the stuff we work on.
Yeah. I thought a really good place to start was actually from like leaving off from what we learned,
Yeah,
what we talked about last week, about Huntington's disease and how it's like a monogenic disorder, which means like we know that like one gene is responsible for it. It's highly penetrant, which means like if you have this gene and you have this many copies or more, you're very likely to show symptoms like physically phenotypes of the disease. And so therefore like genotyping is a fairly good predictor of like what your life after the age of 30 is going to look like. And if you look, or if you like just look through history and also like people that talk to humans, and that some people want to know and some people absolutely do not want to know. They're like, do not tell me any of the things. And I think that's a really good place to start with, like the ethics of it. Because for
yeah,
me, I think so if we talk about a hereditary disease that goes like autosomally dominant through the generations, if your child has it, and like if your child, like let's say you don't want to test, right? Like your generation, the parents, and you had kids, and your generation was like, I don't want to know, but then your kids are like, I really want to know. So their kids go get tested. But like they, once the kid knows their parents too, right? It's like an automatic, like
right. You have yeah,
yeah, if you genotype the child, you have like effectively also genotyped the parents.
yep.
um
Like you either know what genotype your parents have, or you learn like that your family situation is not what you thought it was. Like either one.
that is true. That is also, I didn't even think about that. But yeah. Actually that's actually quite common as well. Like I was gonna say like genotyping, like people going and getting themselves genotyped on a direct to consumer kind of genetic testing have found family. Like this is like a thing. Like people will be like, oh, you have like 50% match with like this many individuals that also took this test, and you're like, I have that many siblings.
Why? Yeah.
Like that has happened. I actually do know someone who did that and like found a long lost sibling, and I was like, wow, um like what are the ethics, like what are the ethical implications of something like this? Like how do we make decisions, like
I
how are
wanted
these decisions made, right?
Yeah, I actually wanted to talk about something that's not strictly a genetic test, although there's kind of a genetic test for it, but it was something. So I was at the Cognitive Neuroscience Society, and they had a workshop on trying to identify the ethical and legal and social issues that were most pressing in neuroscience. And one of the things we talked a lot about was this idea that for Alzheimer's disease, there are now increasingly things that can predict it, and I think this is similar to also like Huntington's disease, same deal. Although, so for Alzheimer's disease, so for about 10 years or so, you have actually been able to do brain scans that can, on a cognitively healthy person, that specifically look for the amyloid proteins that play a role in Alzheimer's disease. And you can say kind of, you have abnormally high levels of these proteins, and that suggests that you are likely to go on to develop Alzheimer's. More recently, the FDA has actually been approving some tests that can look at this just from kind of amyloid levels in the blood, and they found that those have some pretty decent predictive accuracy as well. So I think a similar thing. And so one of the things that we were talking about at this workshop is kind of like, should we do this testing and kind of who should be getting it? Should it be like something that's recommended for everyone over a certain age? Should it be just for people who are kind of at high risk because they know they have a family history of it? Should it, and then kind of what are the ethical implications of that, of any of those decisions?
Oh no, that's like a screening question too,
Uh-huh.
because
Yeah.
like that
Yeah.
happens in cancer. They're
Mhm.
like even before genetics, it's just like mammograms. Like right now, like I think the recommendation is made by a bunch of like doctors, and they're like, okay, what probabilistically will get the most humans that would get breast cancer, for example. So like, what age range should we screen them? Do you know what I
Mhm.
mean? And like that clearly, you look at a Gaussian curve and then like they cut it off, and then clearly there's like a tail bit here that is not being screened. Like then they're like, oh, this age and to this age is like the optimal window to get the most people that will present with cancer. But obviously that screen, you could screen every woman. You could screen
Mhm.
every single woman like
Right.
every 10 years. It's just like a resource thing. It's like,
Mhm.
does and like are you optimally getting to the large population of humans? And then there's a whole bunch of people here in this like little tail, which probabilistically is a small number of humans, but if you count the actual number of humans, these are like thousands of thousands of people that could get this disease that are not being screened because they don't fall under like the the norm and however many standard deviations they think should be screened.
And and I mean, when they're doing the mammogram screening, is exposure to radiation like one of the things they're weighing against, or like the
No,
mammogram recommendations?
mostly it's implementing it because you gotta
I
like
see.
get women to come in and like get scanned. It's not a comfortable experience,
Mhm.
and it's just like a numbers thing.
Yeah. Because like in theory, like there is a point at which like if you're screening people, say at very, very low risk, you're actually would be causing more cases of breast
Oh,
cancer that you're
possibly,
preventing just
sure.
from
By
the radiation
environmental
exposure.
scanning,
Yeah.
we do not want to scare anyone away from doing their actual checkups. I think it's a quite minor amount of like radiation. Like you'll probably get more like hopping on a plane
That's true,
than
but it's like,
one
yeah.
scan. Yeah.
But like I feel like that illustrates like one of the reasons that kind of like that screening is really like it's an ethical question too. It's like okay, we're going to like, because if you deploy something on millions of people, like even if it's something like a small dose of radiation scan, you're like, it's gonna kill some people. Like,
Yeah, absolutely. And just like where do you draw the window, right? Like how many standard deviations from the norm do you draw this window? So like and the people that you don't screen that could possibly would have breast cancer, they will get it really young. Like they're really like out on the edges on the range, but like they probably, do you know what I mean? And that's actually why I think genetic testing could solve these problems. Not completely, just like it could, as in auto, like instead of like just giving you like, you know, hey, you have like a dimple on your cheek, it could be like you are a candidate for early breast cancer screening.
like
Like you
just
should
because it
just
kind
get
of,
it even before you turn 40. Do you know what I mean? Like you should just do it every year after 20, like once a year, just go. Because that's like, do you know what I mean? You're at risk.
yeah. And it's like, because with genetics, you can kind of screen for like a whole bunch of things at once, right?
Yeah, and the problem thing is that unlike most diseases are not like Huntington's, where it's like one gene, this is what happens. A lot of diseases are like multiple genes, and it's like a combination and like not completely penetrant. So like just having this gene doesn't mean, or like just having a mutation on this gene doesn't mean you will have the disease. That's fairly common. It's just like there's a higher probability, and it's like so like you can't like live your life in fear. Like that's the other thing. It's like so stressful. Like knowing is stressful. I think
Mhm.
some people are just like ignorance is bliss, and I should be allowed to live in ignorant bliss, and no one should judge me on it. And vice
Yeah,
versa. If I'm like I want information, like stress me out. Like giving me information will calm me down. It's kind of like I think this showed up in during the pandemic. During the pandemic, the more information I got, the more calm I was. The more unknowns, the more like scared I was. So like I was like really on top of the like learning information.
yeah,
Um
same.
there's I think those are two different kinds. I think there's two routes you can go, and the people who really want to know the information should be allowed to know as much as they want, and also the people who really don't want to know, like, can be allowed to not know for their
Yeah,
personal reasons, because it does change decisions, um like in your daily life, right? For example, in Huntington's, if you know you're, you know, gonna if you carry, you know, a lot of polymorph like if you have a lot of copies of like CAGs in this part of your genome, you're like, hey, maybe I don't want to like have biological children, and like that's a personal choice. Like that's something you want to know before you you know have children.
one thing that came up in this discussion about like these Alzheimer's tests is kind of a lot of people who were opposed to it were saying kind of like, we shouldn't do this testing because it says you're going to get Alzheimer's. There's nothing you can do. And I strongly disagree with that. I think that like, so the argument that I made, which I still think is valid, I kind of started thinking about it there, is that like the test can increase your agency in a lot of ways, even if there isn't a treatment. Like maybe by knowing that you can make decisions about family planning. You can maybe even decide like, oh, I guess I want to donate more money to Alzheimer's research and try and find a treatment. You can make decisions about retirement. Like
Yeah,
it
or
gives you
you're
more
like, I'm
control
gonna buy
over
the
your
yacht now,
life.
and I'm
Yeah.
gonna go boat around the world.
Yeah, but I think like, I mean, I think that's the thing that doesn't get talked about is like knowing that can give you a lot more control over your life, even if it's about something that's medically inevitable.
Yeah, that's us being like optimistic science people that want to know though.
I do think so. Another thing that came up in this discussion, so you were saying like, okay, yeah, people should be able to know or not. But one thing that came up in this discussion that I thought was interesting was about testing of public figures. So, for example, if someone is running for president, should we do an amyloid scan or a test on them? And I mean, actually, this has been happening sort of in that kind of, for example, like there's been a lot of pressure for presidential candidates to take cognitive tests that would show evidence of early dementia.
Yeah, and it happens too. I remember like the day like Hillary Clinton had like a stroke or something. Do you know what I mean? Like that was
Yeah.
on the news everywhere. Like people care. Like if you're the leader of the free world is gonna keel over from a health issue because it's like your nation is gonna be unstable. I do think that's a slippery slope though. Like I do feel really strongly about um like privacy like of health information, mostly because of how it could be used against the person. Not just like career wise, but also like financially, and also like just like the whole eugenics situation where like you can be discriminated against for all sorts of things. Like imagine if they're like, you cannot be a scientist because you were born with these such of genes, which means you will not live that long, and it is not worth it to train you as a scientist because you're not going to have enough time to contribute in your career. So you don't get to go to grad school. You don't get to go to grad school either because, do you know what I mean? Like
Right.
that would
Yeah.
suck.
Yeah, exactly. Yeah. I think like you were talking about last time, I forget if it was on the stream, but that was basically like what the movie Gattaca was about.
Yeah,
Like,
the plot of Gattaca might actually happen
yeah.
if we aren't careful about it. And actually there are some laws. So I wrote down one law which is called the Grace Law. Is that right? No, the Gina Law. I don't know how it
The
translates.
Gina, yeah.
Yeah. So it was passed in like 2008, and basically it's a federal law in the US that's called the Genetic Information Non-Discrimination Act, and it's so that your health insurance premiums cannot be based on any of genetic information. That being said, it doesn't protect against brain scan information like Nathan said earlier, and it also doesn't protect any other company besides healthcare company, or sorry, not healthcare, any specifically health insurance. So other kinds of insurance like life insurance or like end of life care insurance. I wrote a bunch of disability, long term care. Like none of those are protected. So like all of those companies can be like, yeah, you have this gene. It's a pre-existing condition because you got born with this gene. We're not covering you because you're gonna be expensive. Like that is currently the way it is. It is only covered for health insurance right now, and that's just for genetic information and not any of the screens. So, for example, if you got screened for breast cancer or some other cancer, um, like before you bought into a new health insurance, like that cycle, it's a pre-existing thing. I think that's how it works right now. Like that's what?
Although under the Affordable Care Act, kind of they're so they can change your premiums, but they can't exclude you due to
Correct.
pre-existing. Okay, yeah,
Correct. Yeah.
yeah, that's fine.
Yeah, they can just
Um,
charge you more, but they can't kick you out completely. And they have to give you like 90 days notice. And there's like a lot of like, legalese, but like that was to protect people basically in case, you came down with something horrific and you shouldn't
and
break the bank.
it's surprising to me. So this passed in like 2008. So I feel like it was surprisingly forward thinking.
That's true. That was way before any like direct to consumer genetic testing existed. But also like the other thing that's really kind of scary for me is like who owns the data? Like after you done like genetic testing, like where does the data go besides to you? Like the full amount of it, and also like who has access to it afterwards. And so this came in like because there was recently a huge data breach at one of the more popular. Huh?
23andMe.
Yeah, 23andMe had a massive data breach fairly recently, and that's really scary because like now somewhere in the dark web someone owns all of these people's data. Like, and
Yeah, I
like
think
that's
another
scary.
yeah, and like another thing that kind of I think a lot of people don't realize is that like genetic data can't really be anonymized because it is intrinsically unique to you.
Yeah. Yeah, we talked about like polymorphisms last week, but
Right.
like at the beginning
Yeah,
of this.
I was just gonna say like so the way this works is that so like anyone who can basically like anyone who's around you can get like uh, any leftover skin cells, that sort of thing, um, and what you can actually do is you can just kind of like measure basically a very small segment of that DNA and then match it to one of these ones that have leaked, and then they can tell basically any genetic information they want to know about you if you're in that leaked data set.
Yeah. That's mm. That's scary to me. That's like when we do guard my cells.
I mean, like, although when I say it,
Everything.
then I'm kind of like, I mean, okay, technically you could just sequence the cells you collect too, so maybe the leaked data isn't that bad.
Yeah, that's true. I think it's well, if you know what to do with the data. What's scary for me is that okay, so currently the rules are you cannot use genetic information from that particular patient, but you're allowed to use information about location, like what city they live in and where they live in. Like that's information that you're totally allowed to. So imagine if we had like nefarious idea.
Mhm.
Um like we taught a large language model to sift through this data and located all the locations where the different mutations, like certain mutations are, like location wise. And then in those like cities or locations, like urban areas, you can be like, within a 2 mile radius of here, your charge for premium will be this much, and then over
I see.
here it will be
Yeah.
this much. Do you know what I mean? They could do that.
Mhm.
They absolutely could do
Mhm.
that, and that's completely fair. That is legal, and the illegal part is getting their hands on this data, but it's currently just floating around in dark web somewhere. Someone could just get it and be like, "Yep, like hey, this is the hotspot for disease." On one hand, it's like this is how scientists do like epidemiology kind of stuff level stuff, and like they can't get this data because every single person had to consent to get the data. On the other hand, they could like flip it around. Someone could buy this data and it could do exactly
Yeah,
that.
and I think it's an interesting topic. I think like, and I think there's this really kind of weird, uneasy like tension like thing with like scientists and data brokers. I think the thing I'm thinking of is like when there are some researchers who like actually like 10 years ago scraped a bunch of online dating sites, and then they tried to anonymize it and then release it as like a research tool that was basically intended to be like kind of a survey of this population. You could see kind of like what traits correlate with things. You could kind of they had personality questions from people, so they intended it to be like a research tool, but it was released in a way that probably also compromised people's privacy, for example.
Yeah, but with the large language models, like you can delete the training data and
Mhm.
it will
And
still
it's still
work. It'll
included in.
still have the biases. It'll still have, do you know what I mean? It's kind of like I think I read it was like ChatGPT like deleted like book database 1 and book database 2. It's like completely gone. Like they don't have it anywhere on any of their storage devices, and yet ChatGPT still works. Do you know what I mean? It has
Yeah,
the
it's just
it's been
encoded into the
trained
model.
already. You can't
Yeah.
untrain it. I mean, you can shut the whole thing down, but like it's
Yeah.
been trained. It's in the system. Even if you take it out now, it's kind of like that. Like that's what happened. Like this is book set 1, which was entire data breach of 23andMe could be used, right? Slightly creepy.
Other interesting data things, I think. So like with this, so kind of coming back to this question about like screening and public figures. So do you think it's like we just shouldn't do it, or?
Oh, should we do it or should we not do it? I'm okay if they have like a physician that's like a third party physician that's like not their personal physician, that's just like a physical every year, and it's just like
I guess, and like, does the data get publicly released, or
I
like?
think I think the media will do it anyway, right? Like it's kind of like you know how like athletes at the Olympics have to do like a drug test to be
Mhm.
like, are you on steroids and like a list of drugs? There should be like equivalent of like list of drugs you can't be on, or like list of cognitive tests that you must pass, right? And
Mhm.
you just all the athletes do it. Like every single athlete do it. It's not really publicized unless someone gets a negative score or like a bad Do you know what I mean? Unless someone doesn't
Yeah.
breathe, then it's not news, right? So I would feel comfortable if every like person had to go through a physical like an Olympic athlete would have to. I'm cool with that. But I don't want to know unless it's like you know what I mean? Like and
Yeah.
the media will
Unless
know when it's a negative result.
I
And I
guess
don't need to know the details of it, right? Like I don't need the genome of our president or future possible presidents. Like that's TMI, that's their own personal information. Like um just like yeah, he's good. This man or woman is good for 4 years. Like pass. Go.
I guess the thing I wonder about is like, so there's like this problem with when you're screening for like when there's this problem that where you're screening for low risk low risk populations called Bayes' law, which essentially just says that if the thing that you're trying to detect is very rare, most of the time you get a positive, it'll be a false positive. And kind of like I do worry about that when we're talking about like screening of like public figures is like, okay, so if you're screening people who you have no a priori reason to think that like they have Alzheimer's and they have no family history of Alzheimer's, then if you get a false positive or if you get a positive on that test, there's a pretty good chance that it's a false positive. And I don't know, maybe the and like that seems like for a public figure, like a company executive or something, that seems really bad. Like you're kind of you can ruin people's lives because kind of these tests are not 100% accurate. Like
Yeah. I think instead of actually genetic testing, because that's like testing what could possibly happen,
Mhm.
you should test for the phenotypes. So like
I think even the phenotypes, like so these blood tests for Alzheimer's, like so like this one agrees 97% with a lumbar puncture, which is really good. But
no, not that phenotype, like
yeah,
behavioral phenotype, like
uh,
ability to do cognitive tests, um like Stroop tests and things like that, like score a certain like within a range of like this is how well they did at like reaction time and memory and like those kind like things that are relevant to the activity. So like for athletes, it would be like running and jumping or swimming or whatever. For a politician or someone that needs to use their brains, it's like cognitive skills, right? So like make sure they pass the physical. It's kind of like we have a cutoff for like I want to say like most professions that are like physical, like firemen, like if they can't run the mile under a certain amount of time, like they got to retire. Like it's like forced retirement, like you can't run the mile anymore and you can't carry a heavy person in the fire out of a flaming building, like that's your job. So like I'm okay, like firemen have like like a way to like self organize. Do you know what I mean? They
yeah,
make sure that all firemen can do the thing that they're designed to do, or like that's their
right.
job. So like maybe politicians should have like the internal tests. Like we don't need to know the results. It just needs to be like, do you know what I mean? The fireman test,
Yeah,
but
yeah.
for
Like
cognitive skills.
we have them do like I'm not even sure what that would be. Like you like have them decide whether they want to like fire nuclear weapons or not.
Yeah, no, that's what I'm saying. Like, you're gonna hand the keys to someone that could like start a nuclear war. Like,
Yeah.
maybe they should be able to like read this many words a minute and like solve some puzzles on a sheet of paper.
I mean, I feel like I guess maybe I think that one challenge there is like it's very hard to define cognitively like what cognitive skills are necessary to make a decision about a nuclear strike. Like I would I would argue that kind of ideally you just want someone who would never order a nuclear strike and like that's the thing you should test. But like
In general.
yeah, like I mean, and you could actually make an argument like you could say kind of like okay, that's the test. Anyone who like deliberately makes a decision to kill millions of people is not qualified to be the leader of a democracy. Like there's actually an ethical argument that you could make there. I think it gets tricky. Like I guess the overall point I'm making is I think when you're talking about these really complex things, how do you measure it in a reliable way gets even harder, which
Yeah.
I think is like why with like the presidential candidates, people are talking about kind of like they have them take this MOCA, which is it is a test of dementia.
Yeah.
I
And
do
that's
kind
why
of
this
I
is
like
neuroethics too.
yeah
Right? Like that's the whole
yeah.
point of this is talking about it. I think
Yeah,
part of
but I
it.
think like I guess the thing that I think about is like there is actually no evidence that failing on the MOCA means that you're incapable of being a president, for example.
That is probably in most instances is fine. It's kind of like
Yeah.
a firefighter who can like do all the other things. Like they can lift like a body weight, they can like
Mhm.
run up the stairs, and they're like so muscly they just can't run the mile under a certain amount of minutes. And like, that's like their
Yeah.
Achilles heel, and then like we're just testing like running. Do you know what I mean? And I was like, yep,
Right.
this like super buff fire person cannot, run the mile under a certain like whatever time is required. And I'm like why can't you? And they're like, well, we like optimized everything else. You just can't do this one random skill. Conversely, we could also end up with someone that's really good at just passing that one thing and can't do anything else.
Exactly. Yeah, yeah. And you can, I mean, if you take it repeatedly and you practice it, you
Yeah,
can
you
pass
can
it.
improve.
Yeah. Yeah. I do
Yeah.
think like I mean I do like that strategy. I mean I do think that is overall the way to go. I just like the thing that you're talking about is like looking at the phenotypes. I just think it's really tricky. And like the other part of it is like under what conditions do you measure and kind of how many times do you have to fail it? Because there's so much stuff that can like mess you up on that. It's like have you traveled like a lot? Have you shifted like had a large time shift from jet lag recently that is going to cause a very large but temporary like impairment in cognitive function. And I guess I do worry about kind of like that being misinterpreted either accidentally or deliberately. Like you can be like, this person is incompetent, and it's like actually no, they were just getting over a cold, and like we know that impairs cognition.
Yeah, I feel like this has happened in the past too. Like we've had presidents who like were incapacitated, and
Mhm.
like it was like a complete secret from the press,
Mhm.
and like no one knew, and like we only know it from his like I think Woodrow Wilson was like he had like a stroke or something at some point, and he was just completely out of commission for like a good solid amount of time, and they just like ran it out of his office for a hot second, like that's so scary in the modern era, right?
Yep. Yeah,
Yeah,
yeah. I
uh,
think Reagan too, right?
yeah, no, and you can go through history, and there are political leaders across the aisle, like all kind. I mean, our most one of our most famous dictators like suffered from Parkinson's. um, Hitler.
Oh,
Like if you I don't like want to do the movement, but if you notice that the Heil Hitler like pose that people take used to be double armed, and then suddenly after a
and
certain
then
year
it
it
became
became a one armed event because he had to like hide his tremors, and so he would
oh
like
wow,
put one arm in his like shirt and to like hide like unintended movements. um, like
that's good.
like this is a
Today we
thing that
learned
happens.
about learned about the neuroscience of Hitler.
Yeah, no,
um,
just things like that, like it has across history has always been like a thing. Like it's scary when the people that are leading you are ill, and maybe people like maybe they should retire.
Although that segues into a thing that like another thing that I think we were going to talk about, which I think is that people can be ill, or at least like the number of people who are ill, or at least have some type of abnormality, is a lot higher than people assume. And actually, if you do brain imaging or kind of EEG on humans, we actually like get trained on how to deal with what happens when you have a completely healthy person who comes into your lab and you put the sensors on them and you look at it and you're like, what the heck is that?
It's like that doesn't look normal.
It happens not infrequently. And And like it can be, and like honestly, like most of the time it's pretty minor stuff. Like sometimes it's like you have someone coming in for a sleep study and you see evidence of bruxism, which is just where they grind their teeth when they're asleep. And it's like it's not life threatening or anything, but it can be quite painful and it's like treatable. And I think so that's kind of like a mild example of that. And then kind of the more severe examples are like you see someone who has a brain tumor.
I think that there's a story in my graduate program. So in my first year, as part of our graduate program, you could volunteer to be an fMRI, and it would scan you, and then like we'll learn how to analyze the data from an like an MRI scan. Like this is what you do with it. One of the students in a couple years ahead of me, like like discovered something that they did not expect to be there. And
Oh,
like and that, like we're not allowed to diagnose ourselves, but we're like, maybe we should go to the doctor and get it looked at. She's doing well now, so but like bonker.
yeah.
Like it was so like no symptoms, like no phenotype.
Wow.
Yeah, do you know what I
Yeah.
mean? Like
Yeah,
until
yeah.
they put her in an MRI, there was nothing.
Did she, I mean, so did she actually have a disease or is this just
No,
like
she
a
had a whole
benign
ass tumor that
MRI?
had to be
Oh,
removed,
wow.
and then she graduated, got her PhD, not doing very well. It was just like that was the thing. Like, what a hurdle to go through in your first year of grad school. And actually, when I was getting scanned, I had like anxiety about what my brain would look like. Like,
Like,
I
is there
genuinely was like,
anything weird in
yeah,
it?
I was
Yeah.
just like, oh my gosh, I hope it looks textbook. Oh, okay. So that's what I want to talk about. I was like, what's textbook, right? So, when we use like there like 99% of us are about the exact same. There's just a 1% that's different. That's like usually what people say. But there's a lot of polymorphisms that
This
don't
is 1% of people or like 1% of each
our
person?
genome, a genome, a genome.
Oh, I see.
Yeah, yeah.
Yeah.
But like, there's a lot of like polymorphisms between in like places that are not coding that like that just exist. It's just like it's amazing that there is not more. Like, it's amazing that we actually exist without like tentacles coming out of us sometimes. Like there's like so many mutations. Sorry, mutations like when something shitty happens. Mutations when there's a deleterious result. Like just polymorphisms that don't do anything. Is actually quite common. Every one of us probably have a bunch of polymorphism between us.
Polymorphism?
Yeah,
Yeah.
yeah. Like if we're calling like every change, every like accidental frame shift, do you know what I mean? Like every like swap of like one codon, probably every one of us has some. And that's actually the beauty of like the diversity of life, because it gives us things that are different. It gives us all our interesting, like we don't want to look like clones. But it's also like one of the reasons um like diversity is so important, because in every person there's like a probability of having a particular polymorphism version of thing that could be beneficial in some way against and should there be selective pressures in the future, it gives us a better chance. um
Like having just the ability to have that kind of variation is
yeah, like we can see this
yeah.
literally play out with diseases like malaria. You can see like entire populations being pressured by a disease like this mosquito-borne plasmodium uh disease that's been with humans for a really long time. Basically since we started like planting yams or potatoes, we've lived with mosquitoes that like fed on humans, and this plasmodium has been with us. There are humans that have differences in their genome that are beneficial to living with malaria, like not just one way, like multiple ways of being more resistant and surviving to a reproductive age, with like malaria like just rampant in where they lived. Like that wouldn't be possible without the amount of diversity in like the depth of our gene pool. And that's why it's like it's dangerous to be like, this is like the perfect genome, like the one reference genome. And actually, if you work with human genetics, frequently, like even if in the reference genome, like there'll be like usually it's like 20 people. I think that's usually what the reference is made of. You'll see like alternative spliced regions all the time. Like even in genes of interest that do things, like it'll be like, oh, like 40% of them do this and 60% of them are like this in the same spot on this gene. It's like alternately spliced in two different ways, and you're like, oh, okay, cool. And that's completely normal. And like both of the reference genome humans, or all 20 of them, were like, the most average average of average Jane Does and John Does. I think that's what they tried to get when they picked the humans. Actually, that might be a worthy topic, to figure out exactly who the Jane and John Does were that volunteered for the genomes to be sequenced.
I mean, I assume they want to be anonymous, right?
No, not who the person was, but like what they were looking for. Like, did they
Oh, I
try to
see.
find the
Yeah.
most like the tallest man and the shortest man and then the shortest woman? Do
Yeah,
you know what I
like
mean?
how they
Like, were they
select
going
them.
for variety, or were they going for like, the Joe of the middle of the Gaussian curve? Do you know what I mean? Like, were they
Yeah.
trying to get like the middle? Were they
Yeah.
trying to get the edges? And like, I mean, they probably did both. But like by now, there's significantly more genomes to work
They've
with.
just put a lot more into it, yeah.
Yeah,
But yeah,
yeah.
I think that raises this really interesting question about like the variation too. Is like, I think, like I think one of the really interesting things was about, so like you talked about the woman who like discovered she had a brain tumor and she didn't have any symptoms yet. And like obviously that is something you want to get fixed. But like a lot of this variation that we see seems to be not especially consequential in terms of your health. And I mean, I think a lot of the time it's like with the malaria thing, maybe it raises your risk for something, but also lowers your risk for something else, or maybe it's just there's things that just generally don't have much impact on your health. Actually, I think this is a thing that kind of is relevant to neuroethics too. I was struck by during the pandemic, like how much commentary there was about how like closing schools was like altering kind of like the social development and language development of children. And like the thing that I found striking about that was I was like, it was always assumed that like that was a bad thing and kind of there's going to be some bad consequence of it. But when you looked at what are they talking about, what they're basically talking about is kind of like this population of children is behaving slightly differently than like this population of children like a couple of years ago. And like, even when you're like, okay, they know fewer words, that's bad. It's like there's a very small number of people who know exactly the average number of words for their age. Like pretty much everyone actually knows an abnormal number of words.
I was gonna say, like, flash forward 5 years, and I
Right.
bet you they all know the same number of words.
But even statistically, like the number of words can't like. I mean, maybe it's a little bit important. Like, I'm sure you can find correlates of that with some things, but it's like no one knows. Like, there's a tiny number of people who actually know the average number of words, and like 99% of the population is either above the average or below the average. And I think the thing
You're
that
saying
this
it is a bimodal distribution of word
like even
knowing?
if it's a normal distribution, right? So it's like you like the ones who are exactly at the 50th percentile is a very small slice of the population.
That's fair.
And on anything you measure, like personality or word knowledge or kind of like how many people you talk to at recess, like
Yeah.
the vast
The
majority
middle.
of the population is actually going to be not right at the mean level. And I think this is really like from a neuroethics perspective, I would argue that I think a kind of an error that we make in research in general is that we assume that if something is normal or common, that is also like biologically good. So like we're assuming like, okay, that's the healthiest one or kind of good for society. And there's this weird kind of like halo that goes around it that I think is often unmerited and leads to us trying to change things, like spending a lot of effort actually to change things that maybe sometimes are useful, maybe sometimes they're not. But I think it's a weird bias that we have.
Ribeye V says physiologically insignificant difference in the number of words.
Yeah, exactly. Yeah, just like, and I think like, and I think this is I think this is like really. I mean, it actually.
Oh no. Did I lose internet?
Yeah, I mean, it's interesting because like in certain settings, kind of like you will be like with children, for example, kind of they will do tests of various things like the number of words you know, or kind of like how you react to in certain situations. And if you fall in a certain range, that's considered like, oh, you actually need intervention here. And I think one of the concerning things I think is that there isn't a whole lot of evidence on when is that good and when is that bad.
Oh, that's fair. I feel like what make the line, like who draws the line? How do they draw the line? Like this
Yeah.
person needs help, and
Right.
yeah.
And I think the interesting thing is because there's this bias, there's this kind of bias in neuroscience research that the thing that it's like if you have a distribution of a trait, the thing that is closest to the mean of that distribution is actually the best. And I think that sometimes gives you really weird, like that sometimes really just is a bias and it gives you weird results. I think the one that I was thinking about was actually this study that came out a while ago. Let me share it.
Drost.
Oh yeah, yep. Anyway, so this was a study on autism, and as one of the people pointed out, one of these folks on Twitter pointed out, a study found that autistic people had the same morals in public and private, while neurotypical people were more likely to compromise their morals for money. And the study concluded that the autistic people were weirdos. And that actually is kind of, so this is a real study that was in Journal of Neuroscience. And so basically they found the individuals with ASD were much more likely to reject the opportunity to earn money by supporting a bad cause. And then and then and then like when you read this study, kind of what they go on to say is basically that they have found this kind of specific kind of impairment in the autistic individuals, where they have kind of this, like, it's very much like they're like, oh, we found this abnormality in moral reasoning and they're too inflexible. And it's like, and you're reading it and you're kind of like, wait, hang on, but like,
So they
they were
walk the
less
walk. I
likely
mean,
to
or
do
they
it
the
bad.
talk. Yeah, do you know what I mean? Like
Yeah.
they're doing like the morally high ground thing,
Yeah,
and
and this
that
is
makes
so
them
I think
autistic.
this is, you're right. It's like, and so like when you read it, it's kind of, it like it feels a little bit ridiculous.
Wait, can I see the? Is there data like on a graph or something?
Mhm. Yeah, yeah, like they're just like, ah, yes. So like they try to come up with these really weird things. They're like an impossible explanatory factor for why they tend to make moral decisions is that they have behavioral rigidity, a core symptom. And you're like, okay, let's see.
So they're like standing by their beliefs.
Right, but I think it's interesting. It's being framed as like they are like, it's like they made a more moral decision because they have this core neurological deficit of like behavioral rigidity. And it sounds very weird, right? But I
Yeah,
think this is like a very pervasive bias in like a lot of research on the brain.
yeah. That normal typical. Oh, like Ribeye says, "Damn neurotypicals."
Yeah.
I was like, yeah, that's
Yeah.
a pretty
Yeah.
accurate. I
Um,
wonder how many neurotypicals were on the author list and how many were
yeah. And like the weird thing is like you don't really like I mean, people might not be like publicly identified as either, and it's like it's hard to say, but it is strange to me that no one like looked at this and was like, huh. Like it was
Yeah,
weird to me that like no one
it
was
was
like,
reviewed. This was peer
right, no one
reviewed.
was like, what do you think about this discussion section?
Yeah, at least 2 other scientists have read this paper and was like, yeah, let's publish that.
Yeah, anyway, I think that and this has actually happened more than once, specifically in studies of moral reasoning. I think it's an interesting bias in neuroscience. I think it like these papers are really good at illustrating like why like they're good at showing the bias, but I think it also has like other implications for like do you try to get people to act more neurotypical? And the assumption is like if you do that, it's better for them. But I think that that's not always the case.
Yeah. Oh, absolutely. In this case, I don't
Yeah,
want to be neurotypical.
yeah. I mean, it's tricky because it's like there's some things like if you have normal blood pressure, it means like you're the least likely to black out when you stand up, and you're the least likely to die of stroke. So like that's like clear. Like there are cases where the normal thing is also the optimal thing, and I think
That's
in
true.
a lot
Like
of
health
things,
wise.
right? And I think in a lot of things where kind of like I think there's some things where there's a clear evolutionary gradient that has caused that. It's kind of so for example, like in most cases, the normal copy of a gene is the healthiest one because the unhealthy ones get eliminated and don't get replicated through the population. So they are very rare. And in fact, like there's a pretty strong correlation between like how harmful a mutation is, how common it is, where the really harmful mutations are always very rare.
Yeah.
For exactly that reason.
It's also really remarkable to me that we humans actually live longer. Like we keep living longer and longer like every year. Like cuz the evolutionary pressure theoretically doesn't help with this. Cuz like you're like once you're past your reproductive age, like that doesn't apply anymore. And yet we are living longer and longer and older and older. Do you know what I mean? Like it's kind of cool. Like what is
I mean,
directing that evolution?
I mean, mostly us, right? Like, I feel like that's mostly just through our own like force of will to like study these
Yeah,
things,
and not be like
right? Yeah,
malnourished and like
right. Like
um
we're just yeah.
no, I think it's amazing that we can like like sometimes like we're like normal is like the best. Let's like go for that. But also like look at the people that live really long. Like don't you want to be on the long end? Like
Yeah.
of the tail end of like of the most standard deviations away from the norm, like in that direction for
Oh,
aging?
this
Like
was.
don't you want to be the oldest possible you could be?
I mean, not right now, but I want to have the potential to live as
That's
long
true.
as
Like
I
having the
can.
potential,
Yeah.
or
Yeah.
like the the longest ass telomeres possible, like could be useful.
I mean, I've talked about how kind of, oh, what Revive Me says, what if human lifespan is suppressed by evolutionary pressure before and we're just bouncing back?
Like we're
Yeah, I guess
supposed
what
to.
kind of pressure? Yeah.
Oh, like we're actually just supposed to live this long. Like that was actually what we were supposed to live to like Yoda age, and um, there was just like a lot of pressure during. Actually, I don't understand the question. I lost it.
I guess, yeah, I was wondering what the evolutionary pressure means here. I do think, like, in a
Bouncing
lot
back.
of animals, like, there's an evolutionary pressure doesn't like in a lot of prey animals there's very little evolutionary pressure for longevity because the animal gets eaten like after a few years, like pretty much like universally. So like that's probably like why rats and mice live a very short period of time is like there isn't really any benefit for them to be biologically able to live
Yeah.
longer. So maybe some like in theory something like that could happen with humans. What's interesting is I actually, do you know about this? Has like the average age at menopause changed much?
Ooh, that's a good question. Average age of menopause.
I was reading a paper recently that was arguing that kind of the age of menopause was a pretty good proxy for overall kind of like somatic aging.
Ah. Trends in natural menopause. All right, time to read some papers really quick.
Yeah. We can come back to it later if you want to, but like, yeah,
Yeah.
I was curious about that because so if human lifespan was suppressed by evolutionary pressure before, like Rabai was saying, you would expect to see the same thing happening with menopause. Like you would expect to see not just lifespan getting longer, but also the fertile period getting longer. Anyway, yeah. Let's see what else are we. Oh yeah. So but okay, this thing that you were talking about with aging and like it's like, oh, we really like we would want to be able to live a really long time. Like no one wants to die in 5 years, generally speaking. I think this is an interesting thing that we are actually talking about in my class, which was, do you think there's a difference between a treatment that aims to bring people to a healthy level and a treatment that aims to kind of push people beyond that?
I found a paper. Sorry, I was busy finding the paper. Okay, so here is a table. Can you see the table?
Let me pull it up. Yeah.
Okay, here's a table of this is just America. So in the US, like women in the 1950s and 1962 to 2015 to 2018. So they're like blocks of 3 years. And then this is like the proportion of people that first experienced menopause at this age of age 40 to 49, 50 to 64, and then greater than 65. And so like this should add up to be 100, right? 40, 60, 70, 89. Okay, yeah, that's right. So 25% around the 40s to 90s, and then that has gone down to about 15% in so like the early 40s is lowered. This has increased a little bit, and this has also increased a little bit.
Wait, which one has increased? The 50
the 50 to 60 went from 42-ish%, 45% to like 47%, 52%, 47% in the past 10 years. So it's gone up by like 10% in the middle range, and then in the highest range, like 3% from 33-ish. Oh, although like here was in 40, so it does seem to fluctuate. It probably has to do with like the amount of data they could get from like this longitudinal study. So like the range is
yeah, and these columns add up to 100%, right?
Correct. Like
yeah,
this adds up to 100. And like some years had more humans. Like this one only had 700 humans. This one had 1,271 humans. I think they were shooting for like around 1,000. So, I mean, that's pretty good. So, okay, so yes, in the US, it has been increasing. So menopause is hitting women a little bit later than before.
It's like
just broadly in those samples that we showed in this paper.
Yeah, which like could be evolutionary. Like I'm skeptical that it's like a natural selection thing. Like if I had to guess, I would say maybe like hormonal birth control. But
oh, you think birth control can like make it take longer to hit menopause?
I think there's some research on that.
Because like if you just like if your body thinks you're constantly pregnant, then it won't use up the egg, and then it can extend the egg use for later.
Yeah, I mean, let me look it up because I was like, so after I read that paper on like how menopause was a good measure for then I was like, I would do
I am actually so curious if you could just like try and not use your eggs every like you know how you like okay so do you know what I mean, like if you just didn't get a period for like periodic amounts of time, but using hormonal contraceptives, you can just like push off having a period for
Right.
longer, so you can like maintain that uterine lining longer, you can maintain those each egg longer because you wouldn't like swap it out. But I wonder if next time you ovulated, you just like super ovulated a shit ton of eggs. Do you know what I mean? Do you know what I mean?
Yeah.
Like, I don't know if it actually, if it actually will extend the age of at which you would get menopause.
Yeah, so this one says, so this review says kind of using birth control pills during your reproductive years are associated with with later onset of menopause. Some researchers theorize that, so exactly what you were saying, by preventing the release of eggs, birth control pills extend reproductive life, but also maybe it improves the functioning of the follicles. Yeah, I think it's it makes
I've
sense.
never thought
Yeah.
of like taking hormonal contraceptives like as a pro in that regard.
The other thing that's interesting to me about this is like most people when they take like oral contraceptives, like they still do have periods because they take the
Oh yeah, they
placebo
take
ones,
the
right?
placebo
But like
ones.
you don't have to do that. I mean, like
Yeah.
there's like it now seems very like it seems like it's perfectly safe to just not like
Yeah.
and then I feel like if people use birth control that way where they just audit completely and they have menstrual suppression, like that would probably have an even bigger effect than what the normal on menopause than the way that people are using it now.
Yeah. Oh, I
Yeah.
wonder. Dang.
Like
Okay.
if you
Now
were
I want
looking
to. I want to see this plotted with people who are on
like on menstrual
hormonal
suppression therapy. Yeah.
contraceptives during the reproductive years and see if like
Yeah.
their menopause
Mhm.
was later or not. Oh, fascinating. I
And
never.
it's like, I mean, it should be, right? Because it's like you're not depleting the supply of
Those
follicles.
eggs,
Like,
yeah, the
yeah,
eggs are chilling
yeah.
there. The
Uh-huh.
hmm.
Anyway, yeah, that was
Yeah.
so
I think
interesting.
we need more homework before we do an episode on contraception and prolonging the life of eggs.
Yeah. But okay, so one thing that I was asking, which we also talked about in our class, was do you think that ethically there's a difference between a treatment that like treats a disease and a treatment that is used on people who are kind of at the normal level but kind of makes you better? I'm thinking about this,
Oh.
like let's say so a good example is like so it turns out like a lot of Alzheimer's drugs, like because they're symptomatic treatments, they're not targeted at the disease. A lot of Alzheimer's drugs are actually just drugs that make memory better.
No.
So you give them to people who have dementia, and it kind of reduces some of the symptoms of dementia. But actually, if you give them to a healthy person, they also get like kind of equivalently better at
Yeah.
forming and recalling memories. Yeah,
Yeah.
and
You're
it's like you
saying
think that
the
like
ethics
one
of
is
just neuro
yeah.
enhancing drugs, period.
Right. Like specifically in that, like, do you think one is more ethical, or kind of like you would do one but not the other, or
Hmm. Okay, so I do actually have an opinion about this. I think that for neurodegenerative diseases, like this is like their last hope. It was important that these drugs are available to them because they're throwing the kitchen sink at them, because this is a disease we could not fix basically. But for someone that's like completely healthy, feel like for them to take these drugs, I would want these drugs to be tested like through clinical trials separately. That's like not for like end of life like Hail
yeah,
Marys. Do you know what I mean? Just
right.
in case there are side effects. Like I feel like for someone that wants to use neuroenhancing drugs, I would like those tests to be more just like done better when the context of this person is gonna live longer than, do
So
you know what I
the
mean?
acceptable risk, yeah, the acceptable risk is lower for a person than like who's healthy than like for a person who has a
Correct.
terminal disease, for
Yeah,
example.
correct.
Yeah.
Yeah. So I don't want to make it harder for people who do have a terminal disease to get like help and care.
Mhm.
Like I do want that bar to stay low and like if not lower. Like, let them throw the kitchen sink if under their consent. You know what I mean? Like, let them try. Like, if they want to try this, sure. But now that we learned that, hey, they tried these things and it works, and you know, regular Joe, healthy Joe wants to try, we should take those drugs again and put it through tests so that it could go out to regular people and be like, yeah, this is your new caffeine kick that will like help you improve your memory. Yeah, that's my opinion. Like, I'm okay with it. Just
And
like
then you
maybe do the tests again, but for, you know, young people that are, or not just young people, just people that are not, you know, diagnosed with the terminal disease.
Like, you don't have a disease, yeah.
Yeah.
Which is like, it's interesting to me that, like, as far as I'm aware, like, the FDA will like not do that. Like, so kind of like, if you like, they're like, it has to treat a disease, or they won't even kind of let it go through the approval process.
Yeah. Mostly I think it's very expensive to run these trials. Like, it's
Yeah.
really expensive to put people through it, and it doesn't make sense to like run it all over again if there's not going to be a market. Say hello
Right.
to the internet.
What's the title for today?
Today we are doing neuroethics of neurodegenerative diseases.
Oh,
These are Ruby's lab mates.
As you can tell, I'm still in lab.
yeah.
We are real legit scientists.
Yeah.
Yeah, and also we are running out of time. So
True. Yeah.
should we end then?
Yeah. Was there any other things you want to talk about?
I think this is a good spot to end.
Yeah. Cool. Okay. Yeah.
Thank you for joining
Yeah,
us.
well,
We're
fun.
Philosophising.
Nice.
Join us again. Not next week Thursday, the following Thursday.
Yep.
9 o'clock.
Cool.